Hello everyone, this is Dennis, and you're on the Den Electro channel. Today I'm reviewing a BMS for 5 lithium-ion batteries. The front of the BMS looks like this. There are two 2-watt, 3 milliohm resistors. They act as a shunt. They measure current. Next are 4 field effect transistors. Each of them is rated for 25 volts and 56 amps. Finally, there's the BM3451 BMS controller. The back of the board looks like this. Typically, 18,650 lithium-ion batteries are used with these BMS. However, for my purposes, I'll be using batteries from vape pens. They have a capacity of approximately 850 milliamp hours. The batteries are connected to the BMS as follows. The BMS output is in the same place as the input, right here. It looks like this. For now, I've placed the wires from the BMS output into terminal blocks to prevent them from accidentally shorting out. I charge 5 batteries through the BMS at 21 volts. After disconnecting the charger, the batteries display this voltage. The total voltage at the BMS output is 20.7 volts. Next, I'll need twice as many batteries to test the BMS to its limits. To do this, I added 5 more batteries and soldered each one in parallel with the other batteries. The battery voltage remained the same, but the current can be increased significantly. Now let's see how the BMS performs under high current and heavy load. To test this, you need very powerful batteries, and the batteries I'm using can't handle very high current. Therefore, I connected another power source in parallel with them. This is the XY6509 step-down DC-DC converter. It will produce 21 volts and 9 amps. The remaining current will come from the batteries. I have an electronic load connected to the BMS output. You can use it to view the total voltage from the BMS and the load current. And this multimeter will show the voltage of the lowest discharged battery in the battery. I gradually begin to increase the load. Note that the current on the step-down DC-DC converter display is slightly lower than on the electronic load. This is because the remaining current comes from the batteries. And of course, there is a slight error in the readings. The voltage is also slightly lower due to losses in the wires. The current is now 4 amps, everything is working fine. I increase the load further. The current is 10 amps. The load is almost 200 watts. The BMS has already become noticeably hot. The field effect transistors are heating up. I increase the load further. "13 amps. The BMS has become even hotter. 15 amps. The BMS is still working. And 18 amps. My electronic load limit has been reached. There's nowhere else to increase the load. Now I'm reducing the load as my wires are starting to smoke. It turns out the BMS can output 18 amps, but it gets very, very hot. I think the optimal current for it would be around 7 amps. So it remains a mystery whether it has an overcurrent and whether it shuts down or not. Now it's almost the same, but let's see if the BMS shuts down if the battery voltage drops too much. As I already said, This multimeter is connected to the most discharged battery. I won't use a step-down DC-DC converter here. The load will only be on the batteries. There's already a small load. It consumes 400 milliamps. As the load increases, the overall voltage and the voltage on a single battery drop quickly. When the battery voltage reached approximately 2.8 volts, the BMS shut down. After this, the battery voltage rises, but there is no output voltage. To wake up the BMS, apply 20 volts to its output, or disconnect the entire load from its output. Here, I disconnect the load and reconnect it. Now I'll do the same thing again to make sure the experiment works. Just like last time, the BMS shut down when the battery voltage reached 2.8 volts. That's very good. So it's protecting the batteries from damage. Now let's see if this board has short circuit protection. I connected the multimeter to the output. I set its regulator to measure 10 amps through it, and will short circuit. I short the contacts, the ammeter goes off scale, and smoke starts coming from the left side of the batteries. It turns out that one of the power wires between the batteries has burned out. I'm checking the temperature of everything else. Everything is cool, which is good. I'll get a second multimeter and check the current voltage at the output. The multimeter shows 9 volts. It looks like the BMS has gone into protection mode. I'll briefly connect the 20-volt wires and try to wake the BMS up. Now I'll check the BMS output voltage again. The voltage has recovered and is now 19 volts. That's good. I'm shorting the wires again. As a reminder, there's only one battery left connected, as the other one has a burnt-out wire. I poke the probe into the terminal block again. No more sparking. I check the temperature of all the components, and it turns out the remaining battery has a burnt-out wire too. I reconnect it. The multimeter shows 9 volts at the output. I'll apply voltage again to wake up the BMS. I check the output voltage again, and as expected, it's 19 volts. I short circuit for the third time. This time, I'll try to do it really quickly. The ammeter readings have jumped. I insert the probe back into the terminal, and as you can see, the readings are now stable. So the BMS went into protection mode and no wires burned out. I check the output voltage. The multimeter shows 9 volts. I apply voltage to wake up the BMS. And after that, 19 volts appears at its output, as expected. Now let me draw a conclusion from what we saw. The BMS has short circuit protection, but it's very slow to respond. Even though the wires on my batteries are very thin in some places, I don't think they should have burned out. The BMS should respond faster. So if a short circuit occurs for a split second, the BMS shuts down and nothing bad happens. But if its wires are shorted for a long time, as in my case, the wires could burn out, or, even worse, the BMS could burn out. Even during the experiments, I noticed that the BMS does not always work correctly. Here's the deal. If I connect a very powerful load to the BMS and it goes into protection mode because the battery voltage drops too much, then after I remove the load, the BMS should turn on immediately. But this doesn't always happen. Several times I had to wait a minute. and once, even about 5 minutes. Only after that did the BMS turn on. So in cases where I needed to quickly wake the BMS, I had to connect 21 volts from the power supply to its output. The same thing happens with a short circuit. I think the BMS should turn on immediately after clearing the short circuit. But here, I have to wait 1 to 2 minutes, or also connect 21 volts to its input for it to turn on. I might be misunderstanding something here, so if anyone has any thoughts, please leave them in the comments. We've tested all the BMS functions, but there's still a few things left to check. There are 2 more terminals on the back. You can connect a thermistor there. I soldered a 10 kilo ohm NTC thermistor there. The temperature sensor can be used to protect batteries from severe overheating. This usually happens when charging or discharging batteries with very high current. To test whether the BMS's overheat protection is triggered, I'll heat the temperature sensor with a soldering iron. I set the soldering iron temperature to 120 degrees Celsius and connected an LED to the BMS output. When the protection is triggered, the LED will go out. As you can see, the LED goes out. And after the thermistor cools, the BMS turns on again. Now I'll try pressing the thermistor to the soldering iron with my finger and feel how hot the sensor gets. My finger was already burning badly, but I could still hold it. It was impossible to hold it any longer, so I decided to let go. Also, I thought my finger might even be cooling the thermistor. After that, the BMS immediately shut off. Even though my soldering iron temperature was set to 120 degrees, the temperature on its surface was lower. And, it seemed to me, the temperature sensor was probably heating up to 60 or 70 degrees. That will be the temperature at which the overheat protection trips. That's all for today. Like and subscribe to my channel if you haven't already. Ask questions in the comments if anything is unclear. Bye everyone.